Next, I will introduce a left-sided finite limit. As a part of introduction, we will discuss the definition, interpretation, and a few examples. We associate the following behavior around the point a, L with the following limit statement, called the left-sided finite limit. Note that we do not suggest that the graph must approach the point as a horizontal line. It can approach from above, or below, or at a different angle, or in any way in between. The point itself may or may not be a part of the graph, and it is irrelevant what the graph looks like to the right of the point. All of these behaviors are described with the same limit statement and schematically can be expressed with an arrow starting to the left of the point and ending at the point. We say f approaches to L as x approaches to A from the left. So to interpret the left-sided finite limit, we would first read it as f approaches to L as x approaches to A from the left. Then we locate the point a, L on the coordinate plane and draw the following behavior. Note that from the statement alone, we don't know whether the graph approaches L from below or above, or whether the point itself is a part of the graph or not, or anything else about the behavior to the right of the point. The left-sided finite limit statement only tells us what happens to the graph as the input approaches to the target value from the left. For instance, this is what one would imagine when seeing the following limit statement. It shows that f approaches to 2 as x approaches to -1 from the left. And that's all we can learn from the limit statement alone. Let's do an example. Consider a function defined by the following graph. And let's find the following limits. In other words, let's write the left-sided limit statements to describe the behavior of the graph at the following locations. To find the limit, we need to determine the value which the function approaches to as x approaches to -2 from the left. It is easy to see that the function approaches to 1. In other words, f approaches to 1 as x approaches to -2 from the left. Therefore, the answer is 1. So we found the limit. To find the limit, we need to determine the value which the function approaches to as x approaches to 0 from the left. It is easy to see that the function approaches 0. In other words, f approaches to 0 as x approaches to 0 from the left. Therefore, the answer is 0. So we found the limit. To find the limit, we need to determine the value which the function approaches to as x approaches to 2 from the left. It is easy to see that the function approaches 4. In other words, f approaches to 4 as x approaches to 2 from the left. Therefore, the answer is 4. So we found the limit. Finally, to find the last limit, we need to determine the value which the function approaches to as x approaches to 4 from the left. It is easy to see that the function approaches to 2. In other words, f approaches to 2 as x approaches to 4 from the left. Therefore, the answer is 2. So we found the limit. We discussed the definition of a left-sided finite limit using the graphing approach.